Good day, ladies and gentlemen. Okay, calculator. Yeah. Mirror. Yes. I think everything's clear now. I'll come this side a bit. Hey guys. I'm sorry for the inconvenience of yesterday. Yeah. Yesterday, whatever happened, you know? Yeah, I think we are good to go. Okay, no. Nope. Okay. Just here. I think this is going to be clear. Yeah. Thank you very much, guys, for joining, and I hope you're good. So, yeah, I want us to prove this theorem, as we are required to prove. Let me just write proving a plus c is gonna be equals to 180. Just gonna prove that, and yeah, just going to prove that. Yesterday it was unfortunate that we experienced the low power outage and whatsoever, but yeah, the energy is being restored. Yeah, and I'm glad you guys are here today. I hope we are going to have a good understanding to each other. So now what I'm going to do, I'm just going to say RTP. Just going to say RTP. Required to prove that angles, opposite angles of a cyclic quad are supplementary. Not sure if this is a good spelling, or yeah, can I get a spelling? I'm not sure it's supplementary or it's supplementary. I'm not sure, but yeah, you understand. Supplementary, it means that angles being added. Oh, thank you very much. Angles added, they become 180. Like if I add A plus C, they're going to be 180, right? So now let's start, guys. So what is a cyclic quadrilateral? In simple terms, it is a quadrilateral which it is inside the circle. So what is a quadrilateral? Can I ask you something? Can I ask you real quick, what is a quadrilateral? Please someone give me an answer real quick. Oh, required to prove, ne? That's RTP. Because of like we are proving this to be equals to that. We don't know yet that this is gonna be equals to that, but if you've been asked in an exam to prove that A plus C is gonna be equals to 180, so you're going to say I'm required to prove that, obviously. And in an exam, you know the way they structure the question paper, they will just say prove that opposite angles of a cyclic quadrilateral are supplementary, or they will just say prove the theorem which states that opposite angles of a cyclic quadrilateral are supplementary. But at first, what do they like to do? They like to write a statement and they will leave it behind where now you have to complete that statement. Is that clear? So let's start. What is a cyclic what is a quadrilateral? What is a quadrilateral? Let's start there. What is a quadrilateral? So that we can get an understanding. What is a quadrilateral? What is a quadrilateral? Ish. Sometimes these words, eh? Yeah. What is a quadrilateral? What is it that we are talking about? When we talk about a quadrilateral, what is it that we are talking about? In general, not a cyclic quadrilateral, but what is a quadrilateral? It is a type of a polygon in geometry that has four angles, ne? 4 angles, ne? Yes, it's a polygon in geometry that has 4 angles. Yes, vertices. Thank you. Even 4 vertices. You're still correct, my friend. Not equal. No, not 4 sides that are equal. No, not 4 sides that are equal, but 4 angles. Yes, 4 angles. Thank you very much, guys. Ne? So, what do we now? What is a cyclic quadrilateral? It is a quadrilateral inside the circle. Ne? It is a quadrilateral inside the circle. And firstly, when I'm going to explain this, I want you guys to understand. Yes, that adds up to 360 SM. Thank you. SM, thank you for the emphasis, my brother. That's a good emphasis. They add up to 360. It means angle A, angle D, angle C, and angle B. When you add all of those things together, they will give you 360. All points touches the circumference. Yes, the point A, it touches the circumference. Point D, it touches the circumference. Point C, it touches the circumference. And point D, you can see they all touch the circumference. So I'm going to destroy this for the sake of understanding. Ne? Thank you very much, Karabo. Thank you very much. Thank you very much. So for the sake of understanding, I'm just going to destroy this. Ne? And I'm just going to draw something like this. Okay, now let me use the blue one. It's very cold, my guy. So, is this a quadrilateral? Is this a cyclic? And like, is this a quadrilateral? Is this a quadrilateral? I want to ask you a question. Is this a quadrilateral? Is this a quadrilateral, guys? Guys, I'm asking, is this a quadrilateral? Guys, listen to my question. I'm going to ask this for the last time. Is this a quadrilateral? Is this a quadrilateral? Listen to my question. Don't rush. Don't rush. Don't rush to answer. Is this a quadrilateral? Okay. Those who say no. Yes, guys. Yes, it is a quadrilateral because it has 4 sides, guys. It has 4 sides. It is a quadrilateral. You see, I got you. I got you. But here's the next question. Here's the next question. Is this a cyclic quadrilateral? Okay. Unfortunately, I'm Tswana-less. Is this a cyclic quadrilateral? No. Yeah. This is not a cyclic quadrilateral, but it is a quadrilateral, guys, because it has 4 sides, right? Yes, because of it doesn't touch the circumferences, because this last point, it doesn't touch the circumference. Not all points touches on the circle. Thank you. No, because it doesn't touch the circumference. Thank you, Z. You love, you love thriller. Ish. Sorry for mispronouncing, but yeah, not all points they touch the circumference. Thank you very much, guys. Now you get it clear. Now you have an understanding, Hori, what is a quadrilateral and what is a cyclic quadrilateral. Ne? Yeah, I just jogged your mind there. So now let's go back to our cyclic quadrilateral, ne? D. Yes. Now we are back to our cyclic quadrilateral, ne? This is a cyclic quadrilateral because of why? All points they touch the circle. So we have conditions and we have rules that we are using in quadrilaterals, ne? We have conditions and the rules that we are using in quadrilaterals, but now we are going to prove that A plus C is going to be equals to 180. Now we are going to start with the statement, obviously, RTP, required to prove that opposite angles of a cyclic quadrilateral are supplementary. You are not sure, guys. You can't use the conditions of a cyclic quadrilateral while you are not sure for this is a cyclic quadrilateral. Ne? You are not sure. So the first thing that you are going to do, let's help each other. Let's help each other now. We are doing this together. Ne? I know there are those who knows and there are those who doesn't know. So what is the first thing that we have to do? What is the first thing that we have to do when we deal with this kind of construction? Okay. Yes, we are going to construct, guys, ne? Guys, you are going to construct when you are asked to prove a theorem, because of obviously when you've been taught about proving this theorem, you are allowed to construct, ne? But whenever you are solving equations, whenever you are solving what this is equals to that using the conditions of a cyclic quadrilateral, no construction is needed, ne? But now you are going to construct, ne? And guys, whenever you are constructing, you have to state that what are you constructing. You don't just construct and write all your statements. No, you have to state whether that you are going to construct whatever and whatever. So now let's write. You are going to say construct B O and okay O D, ne? So after having this statement and OD, BO and OD, after having this statement, guys, ne? After having this statement, now you start to construct. Askeri, you told us, or no, I'm constructing BO and OD. Now you are going to construct BO. This is the construction line, and now we are going to construct OD. You see now, you constructed now. You have this statement and you construct. Don't forget, you write this statement and you construct. And after, label your angles. Don't forget to label your angles. You don't just construct and leave this thing like this. So you are going to label this thing as O1 and O2. You constructed, it is fine. You are labeling this as O1 and labeling that as O2. So now we are going to take this step by step. No rush, guys. Don't worry. We are not rushing anywhere. So now, which theorem are we going to use that will help us to prove this? I just need you to state it, or maybe you can write it in short. Theorem blah 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 blah, or you can write it or the angle what, or the side what. Which angles? Okay, I can see how people they are saying theorem 2. Theorem 2, theorem 2, theorem 2. All right, thank you very much, everyone. Thank you very much. So why are we using theorem 2? Why are we using theorem 2? I just want to understand that. Why do we need to use theorem 2 in order for us to for this to help us to prove that theorem? Why are we using theorem 2? What do we notice What convinced us to use theorem 2? Ne? We have to know that. We just have to be sure with everything that we do. What convinced us? No, not the midpoint, guys. I just need a simple explanation. It's not a midpoint. Please try. Please try. Please try. Please try. No, okay, we have O, but that's not a specific reason. We have the center, but that's not a specific reason. But it's fine. Guys, we have 2 points. Ne? We have 2 points which subtends the angle at the center, and also they subtend the angle at the circumference. You can say a chord or the arc. Angle subtended from the same arc or from the same chord. They subtend the angle at the center and they subtend the angle at the circumference. That's the reason why we are using theorem 2. Because of these 2 points, we are going to use these 2 points in our advantage in order for us to prove that theorem. So now the first statement that I'm going to write, before anything, I'm going to write okay, I'm going to say O1, angle O1 is going to be equivalent to what? What is my O1 going to be equivalent to? What is my O1 going to be equivalent to? What is my O1 going to be equivalent to? What is my O1 going to be equivalent to? Yes, it's going to be 2A. 2A, guys. It's going to be equals to 2A, not A. 2A, 2A, 2A. Thank you very much. This O1 is going to be equals to 2A, angle 2A. Reason the angle at center is 2 times angle at circum. Is this the correct reason for us to use? Ne? We can write the reason like that, ne? But maybe we should write it in full. I'm not sure. Hey, I did this for a long time, a long time ago, but this is the correct way, ne? Thank you for the verification. Thank you very much, guys. So again, what is going to be our O2? Our O2 is going to be equals to what? What is our A2, our O2 going to be equal to? Angle 2C, guys. Not only C. 2C, guys. 2C. So O2 is going to be equals to 2C, guys. Ne? Don't forget, because sometimes we get people who are saying what O1 is going to be equals to A, O2 is going to be equals to C. Reason, same reason, ne? But don't do like this. Don't do like this in the exam. You are required to write this. Why? Angle at the center is twice the angle at the circum. Another reason. You repeat the very same reason on another line. You don't draw these arrows like this whenever you are writing this on your exam, right? So now I want to ask you. I don't want to answer everything, ne? I don't want to answer everything. I want to ask you, what is O1 plus O2? What is this going to be equals to? And please like and share and follow. Can I get 10K, guys? Can I get 10K? Can I get 10K likes? Can I get 10K likes? Yes. It's going to be equals to 360, right? Yes. This is going to be equals to 360. And what is the reason for that? What is the reason for that? What is the reason for that? It's going to be the angles at the point, the angles around the point. 360. La jigelisa lele. La jigelisa. You are revolving around the same point. Is the angles around the point, ne? Then yes, thank you very much. The angles around the point. So now what am I going to do? I'm going to change this A1 to what? Because since my A1, my O1 is going to be equals to 2A2 and my O2 is going to be equals to 2C. Ne? My O1 is going to be equals to 2A. My O2 is going to be equals to 2C. Guys, like let's teach each other how to close the statements, because that's very important, because there are some other people's, they break here. They don't know what to write also. Ne? So now what are you going to say? Or you will just say this. You're just going to replace this O1 with 2A. Ne? We are replacing this O1 with 2A since they are equal. You see how this script, it makes sense, eh? It makes a perfect sense because of you stated that this is equals to that and that is going to be equals to that. Now you have a right to replace this guy with that guy, and you're just going to say plus O2. You are going to replace this O2 with what? With 2C. Angle 2C, and this is going to be equals to 360. Ne? Here there is no reason. And what are you going to do? You are going to do what? What are you going to do next here? What are you going to do next? What are you going to do next? What are you going to do next? Thank you, Thunder. Thank you, Thunder. Thank you. No, we are not finding the common factor. We are taking out. We are taking out. Ne? We're not finding it. Thank you very much. We are not dividing by 2. We are taking out a common factor. But yes, when you take out a common factor, you'll divide by 2. Thank you. Ne? When you take out a common factor, you're going to divide by 2. But it's fine. You're going to divide by 2. Find the answer. It's still fine. So now you're going to take out a common factor, or you're going to divide by 2. Ne? And I'm going to take this 2 outside. A plus C. Because at the end of the day, is going to be, this one is going to be 360 degrees. And I'm going to divide this by 2 and divide that by 2. So what is A plus C? It's going to be equals to 180. What is A plus C? Yes, you can ask, my friend. Thank you very much. Thank you very much. You can ask. Black Raven. You can ask, my friend. Your what? What you call? Your comment will be pinned. Ne? Your comment will be pinned, my friend. You can ask anything. 180 degrees. So now you see how we proved that A plus C is gonna be equals to 180 degrees. You can see that. Are you happy? What are you wrong about? What are you wrong about? Come back. Come in forward. You see now we proved that A plus C is gonna be equals to 180. We proved, eh? Can I get a thumbs up? Can I get a thumbs up? Can I get a thumbs up? I do lives midnight. Tutoring. I'm doing them during the day. But lately, you have been facing a power outage. But the power is back. Yeah? Can I get a thumbs up? Can I get a thumbs up? Get me to 10K, guys. Let's move. I'm going to close this live while we reach 100Ks. And I don't expect people to fail how to prove this, eh? How to prove this. I'm going to close this live while you get me to 100K. So we are moving. We are going... would I be wrong if I first solve the angle A? That's 90 degrees when using this. So, no, how? No. This is not 90 degrees, guys. Ne? This is not 90 degrees. This is not a straight line. Ne? This is an angle. This is an angle. Ne? This is an angle. This is not a straight line. Ne? And this is not 90 degrees. Ne? And this is not 90 degrees. It is not a diameter. Thank you very much. Ne? Thank you very much. Because this is the side BO and OD. And you can see who B and D, they are not on the straight line. Ne? And even though I were to draw the line here, this is not going to make a diameter. Ne? Are we clear on that part? So is that clear here? Are we clear? Are we clear? Are we clear? Thank you. No semicircle here. It's just pure theorem 2. But I'm saying O2 is 180, then if we would say the angle A. No. Don't miss a point. Don't miss a point, my boy. Look. O1 is going to be equals to 2A. Reason being, the angle at the center is going to be twice the angle at the circumference. But it doesn't mean this angle is 90 degrees. No. Ne? Guys, don't miss a point. Don't miss a point. If maybe I feel like you're not familiar with this theorem 2, I suggest you should go back to theorem 2 and figure out and solve the equations of theorem 2. But don't worry, stick around. Now I'm going to prove another theorem. Ne? Please, guys, can you please get me to 15K in the meantime? In the meantime, I take questions and I help learners. As I'm taking question and help learners, please get me to 15K. Please get me to 15K. 15K. Proportionality. No, let's not rush it. Ne? Let's not rush it. Don't worry, man. Just follow. Follow. Then you'll get proportionality. I don't like to jump from one place to another. Hey, no. Step by step. Ne? Step by step, guys. We are not rushing anywhere. We are doing this step by step. And when we're at 15K, we prove another theorem. 15K, we prove another theorem. Please support. You're not paying for this, guys. And guys, I just want you to see this. I just joined that. My sister, unfortunately, subscribe to my YouTube channel. I'm going to post this live on my YouTube channel. Ne? Unfortunately, but I will just wrap this up. I will just do a short summary. If you are familiar with theorem 2, you just start by constructing BO and OD. That's why I said construct BO and OD. Wabon? So just because of this two, they're of the same arc. These two, they're of the same arc. They subtend the angle at the center and the angle at the circumference. So this is going to be twice that. That's why we said O1 is going to be equals to 2A. The angle at the center is twice the angle at the circumference. This O1 is going to be twice A. Same reason, O2. This is O2. Wait. This is O2. The angle at the center is twice the angle at the circumference. Ne? Then these two, obviously, these are the angle at the centers. Obviously, this O2 is going to be twice the C angle. And after, you're going to say O1 plus O2 is going to be equals to 360. The angles around the point. I'm going there. Quena. This is the next theorem I'm going to prove. The tan one, theorem 9. I'm not going to prove these unnecessary theorems which they are not going to be examined. Ne? This one it's examined. You can be asked in the exam to prove this theorem. That's why I'm taking my time explaining everything step by step. Ne? It's grade 11 and 12. 11 and 12. Ne? Grade 11 and 12. So this is twice that. So since this is going to be twice that, obviously, what are we going to have? We are going to have O1 plus O2 being equals to 360, and it's going to be the angles around the point. Huh? It's going to be angles around the point. So now, since we are having O1 plus O2 is equals to 360, we can proudly substitute O1 with that and O2 with that. So we are going to have 2A and plus 2C. Both of them, they're going to be equals to 360. We take out a common factor of 2, divide by 2 both sides, and you're going to have A plus C. It's going to be equals to 180. Thank you very much for reaching that. So now we are moving. We are moving. Ne? We are moving. Let's move. And guys, okay. Yeah. And I'm going to have my diameter. This center is not proper. Yes. 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 What theorem is this one, guys? What theorem is this one? Let's start by checking this question out, and let's see. What theorem is this one? Let's be busy. What theorem is this one? Yes, it's going to be theorem 9, eh? It's going to be theorem 9. Eh? And guys, today I'm doing 3 proving. I'm going to prove, yes, Tan-Cot theorem. I'm going to do 4. I'm going to prove, after this one, I'm going to prove theorem 2. After this one, I'm proving the proportionality one. Similarity, no. Proportionality theorem. Ne? Thank you very much. So now, I'm going to label this as A, B, and C. So now, what am I going to do? And I have my C1. Okay, before I, no. Okay, yes. C1, C2. No, before I label this C1 to be C1 and C2, because now, let me just say this one is going to be C3. Ne? Let me just label that as C3. So now I want to prove that I want to prove that C3 is gonna be equals to A. Ne? I want to prove that C3 is gonna be equals to A. I want to prove that this angle is gonna be equals to that angle. Ne? I just want to prove that. So how am I going to prove this theorem? Guys, is everything clear before I start? Everything is clear whenever I start. Ne? So I need you to familiarize ourselves with 2 theorems that are going to help us to prove. Yes, thank you very much. So let's familiarize ourselves with two theorems. Which theorems that are going to help us to prove these two angles? This C3, ne? This is going to be our C3. So which theorems, if you are doing maths, let me tell you. This child. Thank you very much, moderator. We don't deal with such. Thank you very much. No. We are not. No, we are proving tan court. Ne? We are proving the tan court theorem. So I need two theorems which will assist us to prove that C3 is going to be equals to A. Which theorems that we are going to use in order for us to prove that C3 is going to be equals to A? Which one are those theorems? I just need to be sure people they're sure with their story or not. Ne? Which theorems that are we going to use in order for us to prove this C3 is going to be equals to A? Thank you very much, Ndivo. Theorem 3 is the first theorem that is going to help us to prove that C3 is going to be equals to A. Another one? No, not alt angles. No, not alternating angles, guys. I disagree. What is another theorem? Theorem 4 is the cyclic quad. No, theorem 9 is the one that we are proving. Theorem 7. Ugana, what is theorem 7? Theorem 5. Wow, 9 and 3 years. I think is theorem 5, 9. Okay, tan chord. No, tan chord is the one that we are proving, guys. Ne? Tan perpendicular to radius. Thank you very much, Dineo. That's theorem. That is the second theorem that we are going to use to prove this. Ne? So now let's make a construction. Tan perpendicular to not radius, my friend. Ne? It's just one radius. Ne? Or tan perpendicular to diameter. Ne? Line drawn from the center perpendicular to the chord. No, not that theorem, my friend. Not that theorem. Please tap the screen, guys. Please tap the screen. Tap the screen. I will start, but tap the screen. Tap the screen. Abo? Tap the screen. Tap the screen. Tap the screen. I don't understand the difference between the theorem because my maths is in Afrikaans. Yo. Yes. You're in trouble, my friend. You're in trouble. So, guys. But it's fine. But please stay put, ne? Please stay put. We are going to try and make sure that we manage this theorems, ne? We are going to. So guys, let's start with the construction. So what is it that we are going to construct? So guys, again, required to prove, okay, RTP, required to prove that C3 is going to be equals to A, ne? Or whatever. The way it depends on it. Yes. Not producing A, my friend. Not producing A. Ne? You came well. We are going to draw the diameter, ne? And we are going to construct. You are very correct, ne? We are going to construct the diameter, which is from where? From point where? Ne? And let me just say this is O. Ne? This is going to be O. We are going to do what? We are going to construct. Ne? Remember, guys, we are teaching ourselves to... thank you very much. I really appreciate those positive words. Abulele, thank you very much, my friend. And God bless you, though. We are teaching ourselves how to write this in the exam when we come about this question. So now we are going to write a construct CO, ne? Don't say construct the diameter, ne? Don't say construct the diameter, ne? We are going to say construct CO to produce another letter, ne? We are going to say construct CO to produce another letter, ne? Let's do that. To produce what? What is the favorite letter? Let's see. I will go with the majority. What letter can we use? Besides A, B, and C, guys. Besides A, B, and C. Yes, this is the first letter that came. Thank you very much. So we are going to say construct CO to produce D. Right? Now we are constructing the CO. First CO. We constructed CO to produce. What is the letter here? What is going to be the letter here? What is going to be the letter here? We are helping each other, guys. Don't forget. We are helping each other here to produce D. Thank you. Ne? And join D O. Or maybe you can say and DO, ne? You can just say and DO. You can just say and DO and leave it like that. And again, no, not DO, sorry. DA. DA. Not DO. DA, ne? It's going to be DA. So now we are going to join the Democratic Alliance, ne? Yes, that's our construction. That's our construction, ne? That is the first thing that you have to do. DA. Thank you very much. It's going to be DA. No, man. Well, why, okay, why DB? Why DB, guys? Why a lot of people, they are missing the concept. If you are joining, guys, if you are joining DB, which means you are proving what this angle is going to be equal to that angle, ne? Don't mess this thing up, ne? Don't mess it up. If you are joining DB, it means you are proving this angle to be equal to that angle. Now we are joining DA. It means we are proving what this angle is going to be equal to that angle. Do you get the difference, guys? Ne? Do you get the difference? Let's not mess each other up. So if we are joining again, I'm repeating, ne? I'm repeating. If you are joining DA, it means you are proving what this angle is going to be equal to that angle, ne? You are going to prove that this angle is going to be equal to that angle. If you are joining DB, it means you are proving what this angle is going to be equal to that angle, ne? And that's why on the question paper they specify or prove that C3 is going to be equal to A. But the moment you join DB, everything is going to be incorrect. Do you get what I'm trying to say here? So now let's start with the first statement. That's good. We named the theorems that we are going to use, like the theorem that we are going to use, ne? For this. We used the theorem, we stated the theorem that we are going to use, which will help us to prove that C3 is going to be equal to A. So let's start, ne? We are going to say what? I'm just going to label this as let me just say this one, or let me just say this is C3 and this one is C2, ne? I'm just going to name that as C2, ne? And this one is going to be my C1, Ne? I'm going to say C1, C2, C3, or maybe let me leave this one. This one is useless to me, so I'm just going to use C2 and C3. It's useless to me, that one. So I'm just going to say what? So the first statement that I'm going to do, I'm going to say, okay, let me just name A1, and A2. So is everything clear here? So is everything clear? Everything is it fine, guys? Everything is fine here. Can I continue from here? Should we continue? Should we continue from here? Everything is it fine? Is everything fine here? Can I get a thumbs up? Or there is something that I'm missing? Thank you very much for the thank you. So now what are we going to do? We are going to say what? Okay, tell me. You're just going to give me the reason. I'm going to state. You're going to give me the reason. I don't want to be selfish and do everything, because you are the one who is learning. I'm not here to prove a point. I'm here to help you. Ne? I'm here to help you. So I'm going to say A1 plus A2 is going to be equals to 90 degrees. Ne? What is the reason? Is this statement correct? Is this statement correct? Thank you. Angle in the semicircle, right? And again, guys, let me go back a bit to this statement. Thank you very much. Really appreciate your participation. Eh? I really appreciate your participation. And again, let's go back to the first statement. Ne? You can even say construct the diameter CO to produce A. Diameter CO to produce A is still fine. Ne? But it depends on how do you want to state that. So this is going to be the diameter. And you know, the diameter, it subtends the angle of 90 degrees because of, you can even prove that with theorem 2. Ne? This angle is 180, and 180 is going to be twice the angle at the circumference. So 180 divided by 2 is going to be 90. So this is going to be 90 degrees. But yeah, you got that. Ne? So this A1 plus A2 is going to be 90 degrees. The reason is the angle at semicircle. Okay, semicircle. Yes. Again, what is the next statement that I'm going to get? What is the next statement that I'm going to get? These ones, you're the ones who are supposed to see it. What about C2 and C3? What about C2 and C3? What's going on with these guys? C2 and C3. What's going on with them? What do we have on C2 and C3? What's going on with C2 and C3? Yes, they are equals to 90 degrees. Thank you very much. So I'm going to write another statement which says that C2 plus C3, they are both, when you add them, they're complementary. Ne? This one is complementary. So C2 plus C3 is going to be equals to 90 degrees. Reason, tan perpendicular to the radius. Ne? This is going to be what? Tan perpendicular to radius. Guys, hey, some people, they will write pep. I don't understand that one. This is the good reason to use it. Tan perpendicular to the radius, ne? Or tan perpendicular to the diameter. Depends on the formula sheet. And I've posted the what you call the reasons on my profile. If you go there, you'll find the formal reasons that you have to use. The formal ones which you have to use. Not radi, guys, not radi. Radius, guys, radius. Ne? Diameter is perpendicular to the tangent. Tangent is perpendicular to the radius. Radius is perpendicular to the tangent. It's the same thing, yeah? So now let's see. Another statement. What is this? Now, what do you see also? What is it that you see? Which radius? OC. OC, isn't it the radius? Yes, no? Isn't it OC a radius? OC is not a radius. Is not OC a radius? Or maybe you don't see the center. Here's the center. Is it not OC a radius? Yes, thank you very much. So now we are going to have C2. Okay, let me just do this with a different color. We are going to have C2 and A2. Do you see the butterfly there? Do you see the butterfly? There's a butterfly there, yeah? So C2 is going to be equals to A2. Do you see that? What is the reason for that? If C2 subtended by the same arc. Thank you. Subtended angle at the same segment. Subtended by the same arc. Ne? Thank you. So I'm going to say C2. Ne? C2 is going to be equals to A2. Ne? Reason, same segment. Ne? I like it when I like it when people write same segment and they specify which segment. Ne? Which segment are we talking about? Or which arc are we talking about? Which segment are we talking about? Or which arc are we talking about? Which segment? Which segment are we talking about? Or which arc are we talking about? Segment. Mr. Sorry about that. Thank you, my friend, for your participating. Thank you very much. That's correct. Yes. Arc DB. When we talk about the arc, we are talking about, you see, this is an arc. The segment is going to be the line. Same segment, same arc. Arc DB. I like it when people, they specify same segment DB. Thank you very much. Thank you for the gift. Thank you very much. Luande, God bless you, my friend. God bless you with many more marks. And I hope this I hope this life you Thank you very much. And now we have the arc DB. And now what are we concluding? I'm going to write both statements, ne? I'm going to write, okay, therefore, ne? I'm going to write, because I'm proving C3 is going to be equals to A1. And get, or let me just say 1 here and 1 here. Ne? 1 here, 1 here. And I'm going to say, I'm proving C3 is going to be equals to A1. So I'm going to say, therefore, I'm writing the first statement. A1 plus A. I always study to prove such theorem. I'm just hoping you've been here, my friend. I'm just hoping you've been here. Please follow, guys. Please follow my live so that you can get more of this content. Ne? Please follow my live. And you see what I'm not rushing anyway. I believe what I'm helping you guys. I'm helping you guys. Ne? And be helped now. Don't be stubborn. Allow your mind to be taught. Relax, breathe. Thank you. Thank you very much. Thank you very much. Lerato. A1 plus A2 is going to be equals to 90 degrees. You just said. Then, obviously, okay, let me just remove this therefore and put it here. Therefore, A1 is going to be equals to 90 degrees minus A2. Ne? This is the first statement that I am quoting, and I'm quoting another statement now relative to C2 and C3. Ne? Then I'm coming to the next statement. I'm going to say C2 plus C3 is going to be equals to 90 degrees. And therefore, ne? You see where I'm writing this? No, it is the same thing. I don't have to give a reason here. It's the same thing. I'm just taking this and that because I'm just rearranging. It's maths. It's just maths. Ne? Yes, proven. Or you can just say proven. Thank you very much. Ne? Okay. Safe. Ne? I think it's safe when I said proven. Let me just write proven. Ne? Because it's just maths here. I'm just doing the math here. Ne? So therefore, I will just take what? Because I'm proving for C3, I'm taking the C2 to the other side. I'm just going to say C2 is going to be equals to. Ne? I'm just going to say C2 is going to be equals to what? C2, no, not C2, C3, man. C3 is going to be equals to 90 degrees minus C2. Ne? This is just proven, but ne? But C2 is going to be equals to A2. Ne? But C2 is going to be equals to A2. Ne? This is also proven. Ne? Then therefore, obviously, you see, Hori. Okay, let me write it properly. But whenever you reach this one, and therefore, you can just conclude and say C3 is going to be equals to A1. Ne? C3 is going to be equals to A1. And let me show. Ish. You see these things of TikTok. TikTok. It has started now. Hey. TikTok.
S V Q C M. S V Q C M.
Okay.
S V Q C M.
Z Q C M I.
P L H A V.
What?
P L H A V. P L H A V.
Okay. Hey. P L H A V. Thank you guys. Thank you. Thank you very much. Ish. Thank you. Hey, thanks. This things, man. Hey. Thank you very much. Eh? So, this thing kills the momentum. It kills the momentum. But it's fine. I'm just going to show you, ne? Because you see, Hore, if maybe I take this statement A1. And I just want to make this thing to be clear to you, ne? If you take A1 is going to be equals to 90 minus A2, and C3 is going to be equals to 90 degrees minus C2. You see, if I'm having C2 is going to be equals to A2, and maybe I can substitute C2 with A2, ne? You see that? I can substitute C2 with A2. Look, if I'm substituting C2 with A2, you can see what A1 and C3, they are equals to the same thing. Is that understandable? Do you get that? And even though I can put this C2 here, because of like C2 is going to be equals to A2, I have a right to substitute this A2 with C2, and they will be equals to the same thing. Do you see that? Is that understandable, guys? Because they are both equals to the same thing, but in different form. This one is going to be equals to A2, and this one is going to be equals to C2. I just want to clarify this part, or don't get confused. Whenever I said but C2 is going to be equals to A2, then therefore C3 is going to be equals to A1. Because of if I put them like this, and if I take this statement, and I can simply, again, I'm repeating, I can simply substitute this with C2. And you can see what A1 and C3, they are both equals to the same thing. It means that A1 and C3, they are equal. They are both equals to the same thing. Is that clear on this theorem? Is this theorem clear to you? Is this theorem clear to you? Is this clear, guys? Is this clear? Is this clear? Is this clear? Can we move? Can we move? Is this clear? Oh, you are people, they are not sure, eh? People, they are not sure. They are not sure, they are not sure, they are not sure. Alright, thank you very much. So can you please like guys? Can we get 30k? Can we get 30k? Which part? I believe that I became slow. I became slow. Please follow my live. Follow for more content like this. Subscribe to my YouTube channel to get a recap for this live. Ne? Can you please specify? Oh, I said, Hori, if I can put this, like you see here, I said C3 is going to be equals to 90. Okay, this here it was A2, and down there it was C2. You see, Hori, if I'm saying this is equals to that, but it is proven, right? So therefore, C3 is going to be equals to A1. This is the theorem. Here is my C3, and here is my A1, right? I can if I remove the construction, I've proven the theorem. That's what I'm saying. If I remove the construction, I've proven the theorem. So this C3 is going to be equals to A1. Because of why? If I put this statement like this, and I'm taking this statement, C2 is going to be equals to A2. C2 and A2, they are the same thing. And 90 and 90, it is the same thing, right? So I can just remove this and put C2. And put C2. Do you see how A1 is going to be equals to the same thing as C3 being equals to the same thing? Am I making sense on that part, guys? Am I making sense? Am I making sense on that part? Or maybe I'm talking alone, eh? So, if, same thing, I can have my A2 here. And you see, Hore, this, it's similar to this statement, right? But both of them, they're equal. I can just remove this C2 and put A2. Because C2, it is equals to A2. Lanswara, man. Lanswara. I hope learns way. Babo. And people, they were just saying repeat, but whenever I say or they understand, they are running away. So I'm moving. I'm moving. I'm moving. But I hope you guys understand, right? I became slow. But if you don't understand, because the people that they are confused, they are not coming. They are not coming forward. And to what? So I'm moving. So thank you very much. So now I want us to do questions. Ne? I want us to do questions before we move to another proving. Before we prove the what, I need us to move to questions so that we can see what we do really understand these things. And in the meantime, can I get 30k, guys? Please, 30k. If you don't understand, follow my link, follow me, and subscribe to my YouTube channel. And my YouTube channel, if maybe no, I can't. But I'm not a formal teacher. Ne? I'm not a formal teacher. I'm just a whispering teacher. I'm whispering to you like, hey, do this. I'm a whispering teacher. Because I don't want Pella, there are teachers here who are watching, eh? Hey, there are teachers who are watching. But I believe this one is full marks. This is full marks. No, there's no estimation, guys. Full marks. We are getting full marks. We are getting full marks. No estimation. Full marks. If it's out of 6, we are getting all the 6. If it's out of 7, we are getting all the 7. Yeah. There's no estimation. Cause if I estimate to you, it's like I'm killing you. You'll be lazy most to get full marks, and I want people to get full marks. Yeah. Please allow me to go 11 and 12 minutes, ne? Yes. Please allow me a few minutes. I'm coming back. I just want to be busy with my PC. Yeah. I'm looking for the questions, eh? Yes. I'm back. Very quick, fast in a hurry. I'm back. I'm back. If I'm back, I'm having this. I'm having a funny question. This one is so fun. This one is so fun. Ne? This one is so fun. And I believe it's so simple. No circle is drawn there. And I'm going to have 5x. I'm going to have x plus 20. And I'm going to have 4x. And I'm going to have 64 degrees. Ne? And I'm going to say all theorem must be constructed. Let me think. Theorem 1 is constructed. Theorem 2 is constructed. Theorem 4 is constructed. And theorem 9 it's constructed. So basically the theorems that are examined, my friend, they all has to be constructed. They wouldn't be asking you to prove theorem 3, I don't think so. Theorem 4, I don't think so. Theorem 5, I don't think so. Oh, theorem 4, they will ask you. What's the question? Oh, okay. SRT and PQ. They're saying prove. Okay, let me remove this. Prove that SRT is a tangent. Yes. Prove that SRT is a tangent. This is going to be 64. I'm going to give you a few minutes. Let's discuss. Let's talk. We are proving that SRT it's a tangent. Let me bring this closer. Yes. So that we can see each other very well. Please like and get me to 35Ks. In the meantime, I'll be watching the comments. You are free to comment. You are free to comment. My brothers and sisters, you are free to comment. I'm confirming for people that are doing right things. What do you think we should do here? In the meantime, can I get a 35? I'm going to start by doing this question while I'm at 35. We are closing this live while we're at 100. What do you think we should do here? Yes, it is a straight line. Then after look, ne? I just want us to have the third eye, ne? What do you use 520x? Okay, solve for x, solve for x, solve for x. Okay, I can see who we are solving for x. And after solving for x, what is it that we have to look for? What is it that we have to prove in order for SRT to be the tangent? What is it that we have to prove? I can see who is this? Sean. Find Q. Why are we finding Q? If we find Q, how is Q going to be helping us? T. How can T can be 64? I can see what people there's 5x has to be equals to Q. All right. I can see what people they are assuming what 5x has to be equals to Q. And yeah, thank you very much for 35, guys. SRT. Okay. Angle SRT. Q must be equals to Q. We need to find Q. R must be 64. Which R? We have 3 R's, guys. Oh, and SRT. SRT is a straight line, guys. Find the X. Find X, then substitute X, then okay. I see you, Zweli. Thank you very much for your participation. I see you, my friend. QRT. Oh, QRT. This one, ne? Yes, we are going to. Yes, thank you very much for your participation, guys. So now let's go back. Thank you for your third eye, ne? Thank you for your third eye. It's going to be Tancourt theorem. So we have to prove that either the angle PRS is going to be equals to 2Q. But I feel like this one is going to be a long process, ne? But let's see. 4 has to be equals to P, right? Then this 4x has to be equals to P, right? So the x that we are going to have, it has to be equals to what? When you substitute the value of x into 5x, it must give us 90. My brother, Sihle, we are not told this is a diameter, ne? I get what you are trying to say, but we are not told that this is a diameter, ne? We are not told. We can't use the theorem that you are thinking, but thanks. I can see your view, ne? But I'm correcting it. We are not told that this is a diameter. If we were told that this it's a diameter, but we are not told, ne? So hence we can't use that concept, ne? So how are we going to solve for x? Here's the question. Now we are starting to solve now. How are we going to solve for x? How are we going to solve for x? Quickly, let's do this question real quick. Real quick. Let's do this question real quick. How can we solve for x here? How do you think we are going to solve for x? Okay, I can see you, Ntando, straight line, angles at the straight line, angles. Oh, Pythagoras. No, we are not using the Pythagoras, yeah? We are dealing with the angles, not the sides. Angles on the straight line, which means the straight line has passed, guys. Ne? Thank you very much. So now, what are we going to use? We are going to use the angles at the straight line. What is it? What's going on with the angles at the straight line? On the straight line, what is going on? I don't know. Tell me. What is going on with the angles at the straight line? On the straight line, what is going on? What is going on? Okay, L, thank you. All right. They add up to 180. Thank you very much. Ne? Thank you very much. I think there's a question. Are we not going to equate? No. Lutando. No. Here's the question. Prove that SRT is a tangent. We are proving that SRT is a tangent. We are not going to equate this and that because we are not sure that SRT is a tangent. All the angles on the straight line are supplementary. Thank you very much, my brother. So now we are going to have what? We are going to say 5x plus x plus 20 degrees plus 4x. It's going to be equals to 180. Ne? Okay, I think this one is far. Let me write this side. Okay, let me write this side. 5x. Yes, it's fine. This side. Plus x plus 20 and plus 4x is going to be equals to 180. Ne? This whole angle. Yes, no? Yes, no? That's what you meant, right? This whole angle is going to equate to 180. Yes, no? Yes, no here? Yes, no? Yes, no? Thank you very much for the confirmation. Thank you very much for the confirmation. So this whole angle is going to be equals to 180. So what is the reason? The reason is going to be angles at the on, maybe let me correct the English, on straight, no, don't switch off when straight line angles of the straight line equals to 180. Finish. No fancy English. No fancy English. So now what are we going to have? We are going to do what? We are going to add the like terms, right? We are going to add the like terms. So we are going to have 5x plus x plus 4x. So 5x plus x plus 4x, I believe this is going to be 6x. 6 plus 4 is going to be 10. So I'm going to have 10x. And I will take this 20 to the other side. Then 10x is going to be equals to 10x is going to be equals to 180 degrees minus 20 degrees. So these two, they are going to give me 10x is going to be equals to 160 degrees. So now, what is it that I'm going to be doing? I'm going to divide both sides with 10, right? Divide both sides with 10, then our x is going to be equals to what? Ne? What is going to be my x? Thank you. Divide by 10. Thank you. Our x is going to be 16. Yes, this one is going to be 16 degrees. Ne? Then I want a yes or no. Are we done after doing this? We proved, we proved, eh? We proved after doing this, we are done, eh? We are done, we are done. Yes, we are not done, ne? We are not done. What do we have? What is it that we have to do? Because we are still proving that SRT is a tangent, right? Yes, we are proving that SRT is a tangent. Yes, we are going to find TR. You said TR what? TRQ. Thank you. We are going to find TRQ. Ne? TRQ. Ne? So we are going to say T ne, angle R Q is going to be equals to 4x, ne? Then since A or X is going to be equals to 160, no, 16, so it's going to be 4 and 16. Then this is going to be equals to what? What is this going to be equals to if we enter this inside the calculator? So it's going to be 64. Thank you very much. So this is going to be 64 degrees. So now we are going to say therefore, now we can conclude, eh? We can conclude now since we are done solving this thing, ne? Thank you, King K. So we are going to say, and now SRT is a tangent, ne? It's a tangent, ne? Reason tan chord theorem. And you specify, guys. You don't just leave it like this. You specify, guys, ne? You are just going to say, after writing the tan chord theorem, you are going to say Q angle R T is going to be equals to P, and reason both equals to 64 degrees. You're done. You are done. Thank you very much. You are done after doing this. You are done. Are you guys happy? 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 Can I get a thumbs up if you are happy? Yeah. Thank you very much. Can you please get me? Yes. No. But the exterior angle, guys, it looks like this. Ne? Please tell me. I want us to help each other. After solving the x, we could still sum. No, it's not necessary. The goal is to prove that SRT is the tangent. Ne? The goal is to prove that SRT is the tangent. Ne? Ne? Wow, what is the converse? But we can just say, you're still correct. You can say converse tan chord. Ne? You can just say converse tan chord or tan chord theorem. I don't think they will make you wrong. Ne? I don't think they will make you wrong. Though you said it's tan chord, or you said converse tan chord. Or I just want to help this one. Yes, you'll get like up until I get to like 45 as I'm helping this guy, because you guys, you have tendencies of not liking my life, and I don't like it. I don't like it when people don't like my life. Like, and I will go live. So I want to ask people, or when they talk about the exterior angle, is this the same thing as this one? Can we have yes or no so that we can close this Can we have yes or no? Is this the same as this guy? Are these two the same thing? Yes. Thank you very much. It's not the same thing. We are closing it, ne? Thank you very much, ne? And guys, ne, for extra lessons and yeah, for quotation, you can search blr.co.cd, but the website, it's under maintenance, but my number, it's still there, ne? If you need assistance, you can see, or whenever you search blr.co.cd, the website is under maintenance, because there are some people who are joining my live and are trying to hack me. You can hack me, Mar. You can hack me, Mar. Eh? How can you hack me? How can you hack me? Mara guys, ay man. Tloelang bo sa thata. Re tlo le rabedisa, wait. Ene modimo o tlo le hotla ka le botsa. Tloelang ho hacker. No website e blogile. Aga bana ba bangwe a ba sa khona ho joina di live. Kante ke eng ke le utlwisa office di hack. Ka itse re le teng. You're hackist. Yeah, we are coming for you. One day, I want you to try again and hack. La hacker, le hacker na le di website. Ay. Tloelang bopelo empe man. Tloelang logic. But guys, if you still need, if you search blrtutoring.co.za, I think, or whenever you go to the browser, don't go to the top link. There's another link which says for our own courses. And if you click it, you'll have the prices. It's just 200 per month. I charge 200 per month per subject. Ne? I do maths, I do physics. 200 per month each subject, maths and physics. Ne? So let's do the next question. And thank you very much for liking my live, guys. Thank you. I really appreciate it. I'm just hating these people who are just coming to my live and check what am I doing. Me, I'm helping students. Huh? I'm checking the question, ne? I'm checking the question. Oh, no, strictly maths and physics. Sorry about that. Ne? Strictly maths and physics. Strictly maths and physics. So now, let's do. Let me choose which one can I do, Mar? Okay. Okay, no, this one is a bit easy. Simply quad. Okay, yeah. Let's do this one. Not this one. No, it's way too complicated. This one. Let me do. Comment. Chemistry. Yes, physical sciences. We cover both physics and chemistry. We cover both physics and chemistry. We are a business, guys. We are a brand, guys. We are there on the internet. Whenever you search BLR tutoring, we are there, guys. We are not taking chances. We are here to help you. But 200 per month. I'm just hating people who are just coming to ish. They are coming and hack. For what reason? Why do you want to hack us? So let me just draw this simple one. This one is gonna look like there's a small circle. There's a small. Okay, there's a small circle. And there's a ish. Yeah. There's a small circle and there's a hey. This one doesn't look like a circle. But it's fine, eh? Okay. And there's Ish, guys will forgive me, ne? Then we're going to have, okay. Ish. Awa. Yeah. Hi guys, you'll forgive me, Shem. Then we're having then 38. We're going to have x, we're going to have y, we're going to have 54 degrees, and we're going to have y, and we are going to have a tangent. My tangent, touch. Yes. What? Mara is the Mara. It's fine. It's representable, guys. It's representable, guys. Yes, thank you very much. So here's my diagram. Here's my diagram. Yes, thank you very much for your patience. Here's my diagram. Now, what do we need to do? What is the question here? Okay, so they are saying calculate the value of the unknown angles. Ne? So we are going to have our B and C, D, and here is going to be A. We are going to have B, T, D, F, and we are going to have E. Yes. So yeah, let's calculate the value of the unknown angles. The value of the unknown angles. So guys, let's like. Thank you for 50k likes, guys. So now we are running over another 50. We are going to get another 50. So how can we solve such questions? What do you see here? What do you see? In the meantime, put me to 55, guys. Please, can we please push my live, guys? Let's push this live to 200k actually. But I'm going to start whenever I see 55. Let's like. Please, can you please like? Okay. Let's see. There's no parallel lines, my brother. And let me just write a question on the top. Find the unknown. Yes. Find the unknown. Let's see. Let's jog our mind. You see, before you do anything, guys, look at the question and have a picture of the theorems that you are going to use and try to link the angles. So this one is going to be B1. Okay, that other angle is, I assume, is useless. Then this one is going to be D1 and Y, and this one is going to be F, of which is, I think, I don't know about that. So now let's try and think. So who can tell me what theorems do you think? So yes, Pavi. So I think me too. I think we are going to use a Tan-Caught theorem. But how are we going to use the Tan-Caught theorem? Let's talk. Yes, thank you, Luvani Munyai Ndayendu. Thank you very much. So now let's see how are we going to use our Tan-Caught theorem. So let's see, how can we link? What is the value that we can find here? There is no radius. There is no parallel lines. There is. Can you please can I ask this question? Is there a cyclic quad here in this diagram? Is there a cyclic quad? Huh? Is there a cyclic quad? There is no cyclic quad, right? So now, or let me label this one to be Y3. Label this one to be Y3. So we have to strategize, We have to strategize by finding the area. Okay, the more I can see, Hore, you have. Okay, all right. So, guys, please push me to 55. Whenever I reach 55, I'm starting. Whenever I reach 55 and I want follows. Please follow my life. You know who you need my help. Follow my life. I'm going live at 12 o'clock every. Okay, tomorrow even and Saturday I will go live at 12 o'clock. Follow my life. You know who you need my help. Follow my life. Subscribe to my YouTube channel. I just need 10 people per live. More will be appreciated. Follow my life. Subscribe. Make sure that you follow me. You will get the help that you need. Abo. Thank you very much. So, guys, 55, I'm starting. All right. I see you, Renate. We first find B1. B1. How can we find B1? All right. Okay. I can see we can find B1. We find B1. Okay. Okay, I can see, guys, what you are hearing somewhere, and I like it whenever people they're communicating. Come on, 800 likes left. 800 likes left. You are on the right track, Clearly. You are on the right track, my dear. Thank you. 500 likes left. Then we are starting. Put me on 55. Then I'm helping you. Thank you very much. So let's start. So guys, we did the Tan-Cot theorem, right? So guys, we find the unknown. We are finding the unknown. Then we can find S using the sum of angle. All right, I see you. You're on the right track. We can find the angle F, the sum of the angles in the triangle. Angle F. How is F gonna help us? How is F is going to help us in this case? So firstly, what is it that we have to determine? So what do we see? What is it that we can find? We can start by finding the B1. Can we find B1? We can find B1, right? We can find B1. We can try and find B1. So what is the value of B1? What is the value? Please give me the value of B1. Those who know it. Then the ones who are a bit lost, I'm going to help you. Don't worry. Give me the value of B1. Thank you very much. So we are going to start by saying B1 is going to be equals to 54, guys. But don't be confused. There's a small circle and there's a big circle, right? And this B1, we can see how this B1, it is related to the small circle and it is related to the big circle, right? So this B1, it is related to the small circle and it is related to the big circle. So now if we are considering the big circle, because now if I'm extracting this diagram, let me just draw another circle and I will have my triangle. I just drew the big circle only for those who don't understand. And we have our E being 54. degrees. And we have our tangent, ne? And we have our B1. So do you see, Hore, this and that is the same thing. I just took out the small circle and I just took out this line. So do you see, Hore, how did we find B1? Is this understandable? Is this a clear construction, guys? Is this a clear one? Let me bring this closer. Are we having a clear view here? Do you see the clear view? Are we having a clear view for B1? Because we can see, Hore, this big circle is going to give us this 54. Ne? And I consider this EBF. This is going to be EBF. Ne? This is EBF. EBF. 54B1. 54B1. So if we are considering this B1, we are subtracting this segment. If you want to see the tan chord, another way of seeing the tan chord, the B1, this B1 is going to be on this segment, this minor segment. After closing this minor segment, the angle that is left on the circumference is going to be equals to the angle that is on another segment. This segment is going to be B1 and this segment is going to carry 54. Both of these angles, they are going to be equal. I'm not sure if I'm making sense here. This B1 is on this segment and this 54 is on the major segment. And this one is on the circumference, and this one, obviously, it is making an angle with the tangent. So this B1 is going to be equals to that E, and they're both equals to 54. So is that understandable? I believe it is understandable, guys, ne? I believe it's understandable. So I just extracted that big circle only so that you can see how is tan chord represented in this diagram. So I'm going to start by saying B1 is going to be 54, and the reason, tan chord theorem. Ne? So now we got the B1. Ne? B1 is going to be 54. So what is it that we can get? So now, what is the value of x? Now what is the value of x? What is the value of x? What is the value of x? Okay, thank you very much. So the value of x is going to be 54. Do you see it? Thank you very much. Thank you. Much appreciation for those who are participating, guys. You're on the right track. So this 54, do you see it? Now, I'm going to extract the small circle now. I'm just going to take out this small circle. So let's take out the small circle. So now let's see. I'm just taking out this small circle and I'm just going to say, and I'm going to draw this small triangle. This is going to be va and va and va. It's over va. Then x is going to be here, and this is going to be my tangent. Yeah. Obviously, we are not drawing this to scale. And this is going to be 54 degrees. And there's my x. So do you see how do we see the tan chord? Look, this is the segment. Ne? This is the segment. Do you see this 54 is on the minor segment? And on the major segment, we have x. Do you see how you apply the tan chord theorem? Some people, they will surprise you. Some people, guys. I want to clarify this, but firstly, let's finish this question and I will come back and talk about the problems that people are making, but it's fine. So now, this 54 on this segment is going to be equals to the x on this segment, on the minor segment. So is that clear, guys? Is that clear to you? Is that clear? Is this clear to you? So that we move. Is this clear? Because I took out B, C, and D. D? Yes. B, C, D. B, C, D. This is the circle. The small circle. And here it's 38. As far as I'm concerned, I just took out this small circle so that I want to see what's going on, what's really going on this circle. So you see, yeah, I'm having the real things here. 54 is going to be equals to x. So thank you very much for your participation. So now I'm going to have B1 is going to be equals to x is going to be equals to 54. Reason Tan-Code theorem. Ne? Or maybe the first one is in the converse. Tan-Code. The first one is in the converse. Which one? Remind me. The first one is the converse and the second one is Tan-Code, ne? If we find D1. No, it depending on your approach. Jackson is gonna depend on your approach. No, it depends on your approach. It's still the same thing. Some people they will just use the angle at the in the triangle that are supplementary. Then later on they will use the straight line, ne? And I don't think it is advisable to find that B3. I wrote it on purpose, that one, but for your own information, you can just find B3 for your own practice, ne? Practice. So B1 is 54. So here's my question. Is CD parallel to EF? Are they parallel? Is CD parallel to EF? Is CD parallel to EF? Yes or no? Is CD parallel to EF? Okay, all right. What is the reason for these two to be parallel? What is the real reason for these two to be parallel? All right, I see Terence. Okay, they have corresponding angles. Thank you. We have to prove first, but it's proven. It's proven. Corresponding angles, ne? Thank you very much. This is going to be corresponding angles because our x is going to be equals to 54. If both of these two, the 54, obviously is going to be a converse of corresponding angles. So this two, there will be, and you can see, what about the tangent? Is ABT parallel to EF? Is ABT parallel to EF? Yes, no? Yes, no? I'm jogging your mind now. The converse is the reverse, ne? Is ABT parallel to the EF? Is this one is very interesting because yeah, is ABT parallel to EF? I see the S's. I see the I'm asking for the last time. Is ABT parallel to EF? I'm seeing the people are fighting, but I'm going to conclude. I'm going to conclude. So the answer is going to be Okay. Okay. Let's see. Let's test, Let's test. ABT parallel to EF. This is corresponding to that, and this. Okay. Nah. So guys, let's calculate for the value of f. If we find f, that's when we can confirm that this is going to be parallel. What is the value of f? As we can get f by using the sum of the interior angle being 180. So if f, it becomes 54, it means they are parallel. If f is not 54, which means they are not parallel. Ne? F is 88. Ne? Let me prove it myself. Okay. Let me see. 54 plus 38 plus f is gonna be 180. I don't have to write a reason. This is just for our own practice, ne? Just for our own practice. I'm just jogging your mind here. So 54 plus 38 is going to be what? 54 plus 38 is going to be 92. This is 92. Okay, let me just say f is going to be equals to 180 minus 92. What is this value? What is this going to be equivalent to? What is this going to be equivalent to? Sorry about that. What is this going to be equivalent to? What is 180 minus 92? 88. So f is going to be 88. So you can see, if we have the z, if we have the z, it means they are not parallel. They are not parallel. Ne? If we had this value to be 54, that's when we were going to say, these two, they are parallel. Ne? But now they are not parallel. This is just for our own interest of learning. They are not parallel. Ne? ABT and EF, they are not parallel. But thank you for your participation, guys. It shows yeah, you are participating. Eh? Please follow. So let's do this one very quick. What is the value of y? How can we find y? Let's do this one quickly. Very quick, fast, in a hurry. I believe we can do this one within a blink of an eye. How can we find the value of y? I don't need the answer. I need an explanation. For those who wants to know what's going on. I need an explanation. How can we find the value of y there? Easy. Yes. The exterior angles of a triangle. Why God that there's only two people who are answering? Okay. Let me emphasize, because people they okay. Let me just emphasize for those who don't know. You can see there are some people who are confused. So we're having this, and we are having our y, and we are having our b, which is 38, and we are having our 54 degrees. So do you see this? Okay, let me ask first. Let me ask C, D. Is this the similar thing with that? Because obviously if we have something like this, and we have x, and we have theta, and we have beta. So x is going to be equals to theta plus beta. X is going to be equals to theta plus beta. Reason, the sum of the exterior angle of a triangle. Let me just move this to the side and bring this closer. We're bringing this closer. We are learning today. So this is going to be exterior angle, xt angle of a triangle is going to be equals to 2 interior opposite angles. Is this correct? Let's confirm. Asker, we are learning together. Is this correct? Is this the correct reason for this one? Is this the correct reason? Is this the correct reason? Thank you very much. Thank you very much. So now it means we can answer the question now. What is my theta? What is my x? Okay, my x is going to be y is going to be equals to. What is my theta going to be in this case? What is my theta going to be in this case? Okay, my theta is going to be 38 degrees. Thank you very much. And my beta is going to be what? What is going to be my beta? Thank you. So plus 54 degrees. So what is my answer for y? So what is my y going to be? What is my y going to be? 92 degrees. Thank you very much. We are done with this question. We are done with this question. 92 degrees. Thank you very much. So we got the value of x and we got the value of y. So our y is going to be equals to 92 degrees. Thank you very much. This, we use that to got that. You still want to find D1? Wow, guys. The co-interior angles. If you found F, ne? If maybe you found F, but this one is going to be the longest method because this, we found this one to be 88. But firstly, you have to prove or receive D is going to be parallel to EF. After proving that, you find F. After proving F, you are using the co-interior angles. That one is going to be the long process, eh? But you are still correct though. I'm still condoning that. You are still correct. Ne? You are still correct. And I'm still with you on that part. Ne? I'm not discouraging you. You are still correct. But this is the shortest way of finding them. I find a problem in understanding the Toncourt theorem. You at the right place, my friend. You're at the right place. Because we are dealing with the various questions. We are dealing with various questions. We are dealing with various questions relative to this Toncourt theorem. And now I want us to move to radis, ne? To radii. To radii. Let's move to the radii. Thank you very much, guys. Thank you. Let's move. Is there any question here? Is there any question? Who want to, is there any question? Any question? Before we move, is there any question? Is there any question? No question. So I believe already we have to move. Let's move. In the meantime, can I get a 70 key? Toncourt theorem. So I just drew this one, 54, and the tangent to the large circle, 54, it is related to E. And E, it was the given 54. Then this is going to be a Toncourt theorem. Minor segment, major segment. The angle on the minor segment is going to be equals to the angle on the major segment. Toncourt theorem. Ne? Let's move. Let's move. Let's see on what kind of the questions that we are having. Let's do the radis. Let's stop with this numbering. Now we are proving things to be a tangent, things to be what, and things to be what. Ne? I want us to start I want an interesting question. How is this question going to be? Can I get a 70k likes? Can I get a 70k likes? Can I get a 70k likes as I'm looking for the question? Okay, example 5, exercise 1. This is the diameter proven. This one is easy. These questions got it. They were. Yeah, here's the question. Here's the question. Ish, but this drawing is a bit complicated. The question, okay, let me just draw. Please follow, guys. The hacker, busy the hacker bafethu re tlo le kry mo re le kry-ang teng le tlo patala yo le busy la hacker la nana nka re tlile ka go dlala mo di hacker re le lebeletse di-developer nyana tse la drawing yane di hacker and ro bone motšhana ra itse ro teng wa re monitara we busy o nyaka gore hacker nka hacker rena wena It's going to be I know, but they don't look so parallel, but I don't have a choice here. We are having C, we are having P, we are having F, we are having A. 1, 2, 3, and 4. And we are having D, 1 and 2. We are having 4, 3, 2, and 1. And we are having B. What is going to be our B? 1, 2, 3. Oh, this line, it continues. Yeah. All right. Okay. And okay, B 4. 1, 1, 2, 3, and 4, and 1 and 2. Remonat. Is the diagram clear, guys? Is the diagram clear and visible? Is the diagram clear and visible? Yes. Is the diagram clear and visible? Thank you very much. Thank you very much. You are going to be found. You are going to be found, my brother. You are going to be found. Thank you very much for 70. Thank you very much. Not 8B. We are going to bring it closer, my brother. So we're going to bring it closer. I believe now it's clear. So if it's clear on my side, I believe everything is clear. So here's the question. They are saying PA and PC, they are tangents. Alright. PA and PC, they're tangents, right? Can I get a yes or no? We are confirming now. We are confirming the diagram. Can I get a yes or no? Because I'm reading the statement and I want you to confirm. Ne? PA and PC, they're tangents. Ne? Alright, thank you very much. And now AD and PC, they are parallel. Ne? AD and PC, they are parallel. Is that correct? Because I want to confirm whether I drew the correct diagram. Ne? Thank you, thank you, thank you. And they're saying, this one's CB cast the line to meet AP. CB cast the line to meet AP. I don't think and AB, AC, and DC are drawn. Okay, now they're saying prove. The first question says prove. All the questions they are going to be proving. Ne? Prove. First one. Ne? The first one, it says AC bisects P angle AD. P angle AD. What is to bisect, guys? What is to bisect? Seyiqalile le ndaba le. Sesiqalile manje. Sesiqalile. Okay, yes. Yeah. What is to bisect? To cut into two equal. Yes, thank you very much. To bisect is to cut into two equal. So if by looking at the diagram, if they are saying we bisect P angle AD, what must happen in your thinking? Because now we want to have that third eye, that eye which stays here, that third eye, in order for us to have the clear vision of this question. What must happen? What is the first thing that comes in your mind when you have the question like this? What is the first thing that comes in your mind? PA is equals to PD. No, nah. PA is gonna be equals to PD. We are not sure, but nah. That's not the thing that has to put. A4 and A3 has to be equals to what? Must be equals to A2. Yes, okay, that one. A34 must be equals to A1 and 2. 1 and 1 and 2, ne? Okay, so this A4 and A3 has to be equals to A2, ne? A4 and A3 has to be equals to A2. So now let's look for how are we going to do that. So now since we are doing that, Wabona guys, we are stopping to like I'm going to start whenever this it has to be, my life has to be on the 75. It has to be reaching 75. I'm starting. Now I'm talking to you on the comment section. So yes, you are correct. We have to prove that A4 and A3 is going to be equals to A2. And how are we going to prove that? How are we going to prove that? How are we going to prove that? Ne? Because of the information that we are getting, we have the parallel lines. Ne? Just look at the parallel lines. Ne? And how are we going to prove that A4 and A3 they are going to be equals to A2 to answer this question? I'm going to start whenever we add 75%. Let's talk. I'm confirming answers on the comment section. Let's talk. How are we going to do that? How are we going to do that? Daryl Hazel, I see you, my friend. I see you. Yeah. PC and PA turn from the same. No, not yet. I see you see the theorem, but no, not yet. So I want us to I want us to see something. I want us to come up with something. Askeri, I gave you the clue. We have to prove that A4 plus A3 has to be equals to A2 to prove the line AC, it bisects P angle AD. It cuts P angle AD into half. How are we going to do that? How are we going to do that? Okay. I'm starting. So now guys, ne? So the first thing that we are going to look at is what are we going to look at? We are going to look at A4 and A3, ne? And C1 and C2. Ngana, what is the theorem that talks about the tangent outside? Yeah? So now we have to write the first statement. We are going to say what? I'm starting now. We are going to say PC is going to be equals to PE. Hey, there's someone who wrote this, ne? I'm sorry, but you're correct, eh? I'm sorry, but you're correct. And I said no, ne? There's someone who wrote this. I'm sorry, but you're correct, my friend. Yes, tangent from the same point. Which point? I need to know how the people they understand this theorem. Which point? Thank you, Dimpo. Thank you. Yes, point P. Tangents from the same point P. Thank you very much. These are the tangents which they start from the same point and they produced similar angles. Ne? We are going to start there. Ne? And we are going to write this, obviously. Firstly, the tangent from the same point. Obviously, we are going to say, for our reason, tan. Okay, let me write it full. I'm not sure how to write tangent from same point. right? And what's another statement that we are going to write? See, hey, let me read this paragraph. C1, 2 equals to A3, A4, opposite angle. Okay, I see you. All right, so again, very correct. Santandi. Hi, David. Yes, thank you. So we are going to say angle C1 plus angle C2. It will switch off right now. Angle C1 and angle C2 is going to be equals to this angle, guys. This angle. Angle C1 plus angle C2 is going to be equals to angle A3 plus angle A4. Reason angle opposite equal sides. That's the reason. Okay. The reason being is going to be angle. Let me see. Yeah. Come on. I don't have a space, guys. All right, I will just shift and shift. So it's going to be angles opposite equal side. Angle opposite equal side. So let's go back to the diagram. So this angle is going to be equals to that angle. Angle opposite equal side. Angle opposite equal side. So now we got the angle opposite equal side, and we got C1 being equals to A2. Let's go back to our diagram. So what is it that we see? What else that we see? What is it that we see? What is it that we see? Oh, yes. Thank you. A4. Thank you very much. So what is it that we see? What is it that we see? What is it that we see? So we see the parallel lines, So we see the parallel lines. These are two parallel lines, and these parallel lines, they are forming the Z shape. And if we can see, we have that A2 there, and they are forming the Z shape. The Z shape. This is the Z shape, Z shape, Z shape, Z shape. So now I'm going to say what? I'm going to say C1 plus C2, so they are going to be equals to A2. Reason alt. The reason is going to be what? It's going to be alternating angles. Alt angles. Guys, let me give you a tip. Whenever you are dealing with alt angles, you have to specify which angles that are parallel. You specify that these are the parallel angles. You don't just say alt angles and you leave it like that. So now I'm going to say AD is parallel to PC. Here they are parallel. AD, they are parallel to DC, right? So now, what is the last statement? No, not PA and PC. No, not PA and PC. Nandipa, not PA and PC. Not PA and PC. So PC is parallel to AD. PC is going to be parallel to AD. So therefore, what is the last statement that we are going to pose? What is the last statement? Because of we are proving that AC bisects this guy. AC bisects P angle AD. It means what we are proving these two angles, they are equal, right? We are proving that AC, PC, let me show the diagram. P angle AD, I mean, P angle AD, it is bisected by DC. AC, I mean, AC bisects P angle AD, is bisected by CA. So now, what is the last statement? We are going to say angle A3 plus A4. Ne? A3 plus A4 is going to be equals to A2. Oh, before that, we have to specify A3 plus A4 is going to be equals to A2. Reason both, this is the reason both equals to C1 plus C2. You have to specify why they are equal. You have to specify why they are equal. A3 plus A4 is going to be equals to A2. Why are they equal? They are both equals to C1 and C2. Therefore, CA bisects P angle AD. Then chaile guys, chaile. Is that clear? Is that clear, guys? Can I get a thumbs up? Can I get a thumbs up? Is that clear? Can I get a thumbs up? Can I get a thumbs up? Can I get a thumbs up? Thank you. Thank you. Yes, it is necessary. Why is it A3 plus A4 is going to be equals to A2? But depends on who is going to mark. It depends. Yeah. But for me, it's necessary because I have to know why are you saying A3 and A4? Why are they equal? They are both related to C1 and C2. Hence, CA bisects P angle AD. I feel like it's necessary for me. Is that clear? Thank you very much. Thank you very much. Wabon. Can I get a thumbs up? So now the next question, if we are done here, the next question, can you please get me to 80K? We do the next question. Now last stop or like Habiano. Last stop or like Habiano. Like the life, like the life, like the life, guys. Like the life. Like the life. Can you please like the life? Like the life, like the life. 80K, we move to the next question. Thank you very much. And guys, follow, please follow, subscribe to my YouTube channel, follow, subscribe to my YouTube channel, follow, like and share. Like, share and follow, subscribe. I'm moving. If you didn't understand, you'll get the recap on my YouTube channel. I'm getting 80K. We are moving to the next question. We get 80K, we are moving to the next question. And guys, as for my website, for those who just joined, the website, it is under maintenance, but there's a number. We left the number there. We left the number, and whenever you type or a BLR tutoring, you will get our logo, the very same logo that we have put there, and me and Mrs. TK, the very same logo. You will see it on the internet. You just click. And there's it will show you the website is under maintenance because like we have hackers here, people who are acting smart. I don't know what are they hoping for when they hack me. Babo. P angle AD. P angle AD. P angle AD. Here is it. P angle AD. P angle AD. P vertices AD. So let's do question number 2. Right. Yes, so the next question is going to be number B. So the next question, it says we have to prove, we are proving, ne guys? Angle B1 is going to be equals to angle B3. Angle B1 is going to be equals to angle B3. Yeah, this one is going to be the hot one. It's the same thing, because obviously A is on the middle. Whenever you say angle PAD, it means what the A is going to be the vertices. So it's going to be P angle AD or angle PAD. It's the same thing. So we are going to prove that where is it? B1 and yeah, B1 and B3 are the same. Yeah. This one is going to be the hot one. Eh? Is it going to be the hot one? Please like the live, guys. Like the live. Like the live, share the live, like the live. So let me show you the diagram and just take a look at it. So what is it that we can use in order for us to prove that B1 is going to be equals to B3? B1 is going to be equals to B3. So let me ask you a question, guys. No, let's not rush. Ne? Let's not rush. Do we have a cyclic quad there in this diagram? Do we have a cyclic quad? Yes, no? Do we have a cyclic quad? Thank you very much. Thank you very much. So if we have a cyclic quad, can you please label for me the cyclic quad? Which cyclic quad are we having? What is the cyclic quad? Let's say I don't know, and I'm asking you, which one is the cyclic quad? Can you please label it for me? A, B, C. Yes, it's going to be A, B, C, D. Why are we saying A, B, C, D is a cyclic quad? It is a cyclic quadrilateral. Why are we saying it is a cyclic quad? Because of all the points they lie on the circumference. Ne? All the points they lie on the circumference. So these are the things that we have to check, guys. Ne? Thank you, Kwena. Thank you. Points they lie on the circumference. Thank you very much. A is on the circumference, B is on the circumference, and C is on the circumference, and the D is going to be on the circumference. So that's why we are saying A, B, C, D is a cyclic quad. So let's look at that B3. Yeah, B3. So how are we going to prove that B1 is going to be equals to B3? Yes, yes. It's going to be a match, ne? It's going to be a match, ne? But it's possible, though. Me, I see the answer, but I want to help you. I don't want to say much, but I see the answer, ne? But I see the answer. All right, Daryl Azel. Guys, here we are not using the time code. The reason that I asked you about the cyclic quadrilateral, I wanted you to see something, ne? And I'm hoping you are seeing it. That's something, ne? The reason that I ask you, thank you very much. Thank you very much, Gwena. God bless you. And I am hoping this life, it works for you, eh? We always appreciate positivity in this home, ne? Warmth, heart, positivity. Thank you very much. So I wanted you to see something, ne? So now we are going to see the exterior, ne? So now I'm going to have my B3. B3 being equals to what? Obviously, I'm going to leave this B3, and this B3, I'm going to jump one vertices, and the second vertices that I'm going to be focusing on is going to be equals to the exterior. Always look for the points. The exterior, which is B3, you jump one vertices and you move to this vertices. And the whole angle for that vertices is going to be equals to the exterior angle. That's how you see how this two, they are going to be equal. Ne? So I'm going to have B3 is going to be equals to what? D1 plus D2. Ne? What is B3 exterior angles of a quad? Yes, thank you very much. Chinese. So, yeah, sifunda ngo-3 ekuseni. Ufuna ukulala. Uyazi ukuthi une-knowledge gap. Ungalala ungana-knowledge gap. Wena uyekele nama-crying emojis. So siblokisa nge-TikTok wena. This is going to be equals to D1 plus D2 is going to be exterior angle of is not visible. So I no longer need that. Let me bring this closer. Yeah. Exterior angle of cyclic quad is going to be equals to the opposite. This is the interior opposite angle of a cyclic quad. Yes, the reasoning is way too long. I hate long reasoning. Ne? So let me take this back so that people they can see. Okay, now let's go back to the diagram. So now what is it that we have to do? So now we know B3 is going to be equals to D1 plus D2, ne? So now what is it that we know? Can we use tan cot here? Is tan cot okay, let's go back to the diagram real quick. So because we know B3 is going to be equals to what? And B as a whole equals to D1, D2, the A1, the A up to 360. No. I'm going to help you now. Then B3. And then B as a whole. No. I'm going to help you. Yes, you are correct. But I don't think that it will help you in this case, ne? But I'm going to help you now. Ne? Let's try and make this thing to be less complicated. Ne? We are trying to minimize complications. We are trying to minimize the complications. Ne? So we got D3 is going to be equals to the whole D1 and D2. Guys, let me give you a tip. The moment you saw B3 is going to be equals to this one, D1 and D2, don't shift your eyes. Ne? Don't shift your eyes here. Now we are here. We moved from this point to this point. We don't shift our eyes. Now we are going to look for the angle which is going to be equals to D1 and D2. Ne? So we are not going to shift our eyes. So now let's try. Then now let's see. Do we see PA? Is PA a tangent? No, we don't have a center. I don't think we have a center here. Is PA a tangent? Let's focus on the tangent now. Is PA a tangent? Let me do this. Is PA a tangent? Yes or no? Is PA a tangent? The lines that are parallel is AD and PC. Ne? AD and PC. And I don't think we're parallel lines, they will help us in this case. Thank you very much. So let's focus on, do you see Hore D1? Do you see Hore okay. Last time we proved that this one is going to be equal to this one. Last time we proved that these two, they bisected each other. Yes, so let me highlight them like that. We proved that these two, they bisected each other. I think that information we are going to need it. Ne? With this information, we are going to need it. So now, let's see. D1 plus D2 is going to be equals to what? Okay, I can see other people, they are not giving me the answer, so I'm going to help this time. So this time it's me who is coming forward now. So you can see who A1, angle A1 plus angle A2 is going to be equals to D1 plus D2. Ne? What is the reason? Tell me the reason. What is the reason here? What is the reason? What is the reason for this incident? What is the reason? Guys, come on. What is the reason here? We have to finish up. Yes, it's going to be time caught theorem. Ne? Yes. So we saw Hore A4 plus A3. Ne? How? Impossible. How? Ow, guys. Now I have to go back and explain how time code works. Eh? Guys, we have a triangle. A, C, D. We have the minor segment. This minor segment, it covers A4 and A3. Do you see it? And this is the major segment. Here's the angle here. Guys, come on, guys. Okay, let me take it out. Guys, we have triangle ACD. Let's see. A, C, D. And this and that, we have a tangent which passes through like this. This angle, it's A3 and A4. Do you see it? This full angle, it's A3 and A4. Do you agree? Do you, Mara guys, who's saying what I'm wrong? Is there anyone who's seeing what I'm seeing here? Is there anyone who's seeing what I'm seeing here? Can I get a yes, no? Can I get a yes, no? Can I get a yes, no? Oh, A1 and A2, yes, that's the mistake that I did. 3 and 4, ne? Oh, ish. I'm tired, guys. I'm tired. Mara guys, don't make everything simple. Why are you making my life very serious? Why are you making my life difficult? Why are you making my life very difficult, guys? You must say incorrect, check, whatever. But thank you very much for that verification. I wouldn't say, but here, now is it understandable? Maybe like it's just a typing error, guys. Is it understandable? You are back now. You are back. Can we move? We are back, ne? Thank you very much. Let's move. Ish. And I was so sure, eh? And I was so sure. But thanks for your participation. It shows Uriah. You're with me. So we have A3 and A4 being equals to D1 and D2. Tancourt theorem. My eyes were there, but it's just a shift of things. So now, remember, we proved that A4 and A3 is going to be equals to which chord? The chord AC. The AC is the chord, guys. The AC is going to be the chord, and the tangent, which is going to be PE. The chord AC, tangent TA. Chord AC, tangent TA. Got people there. Let's see. So now, remember, we proved that A4, A3 plus A4 is going to be equals to A2, right? We proved that A3 plus A4 is gonna be equals to A2, right? Reason proven on the previous question, right? This one, we agree, Mus. We all agree on that one. We proved it on the previous question that CA, it bisects P angle AC. We proved that, right? You thought it's a diameter. Thank you. Now, since we've proved this, you see now where we have a butterfly. Do you see the butterfly? You have to be careful, guys. Do you see the butterfly? A3 and 4 equals to B1 because B1 is equals to A2. Alright, you're correct. But I thought you are concluding the statement, my friend. Conclude, eh? Conclude. But it's fine. I will conclude for you. Now we are going to say A2 is going to be equals to A2 is going to be equals to B1, ne? A2 is going to be equals to B1, ne? A2 is going to be equals to B1. Reason, same segment, ne? When you the one who's supposed to write warawara subtended by warawara, me I will use this one of same segment, ne? Same segment. Which segment? Same segment. Which segment? Me I like to be clear with my statements, ne? Same segment. Which segment? DC. DC, it subtends B1 and it also subtends A2. B1, A2 points, ne, on the circumference. Remember, B1, A2, ne, points on the circumference, ne. That's why A2 is going to be equals to B1. Same segment. Which segment? CD. I don't know. It is my nature. You are late because we don't have a circle. We don't have a circle. Oh, the center. I get it. Same segment. So now we concluded. So now we are done. So the last statement you can see here B3 is going to be equals to B1. 1. You can see your reason. What is the reason if we have a scenario like this? D1 is going to be equal to that, and that is going to be equal to that, that is going to be equal to that. I think it's proven. It's going to be proven. Guys, help me here. What do we write as a reason? No reason. Eh? Is it no reason or proven? No reason or proven, because I can't say both equals to, because hey, there's a lot that is going on here. Yes, okay, it means what I will stick to no reason. Eh? Yes, proven. You can just say proven. Yes. Proven, no reason. Yeah, that's closer. So, last question of the day. Hey. I wanna, guys, whenever you want to study maths, hey, needs a heart, guys. If you have a banana heart, I'm saying this even now. If you have a banana heart, you won't do maths. If you are taking chances, you won't do maths. If you have a banana heart, maths will tell you. Okay, you want to copy. Copy. Screenshot, don't copy pay. How? Pela is technology pay. What is a chord? Is the line that it is from circumference to circumference. This is a chord. It doesn't pass through the center. This is a chord. This is the line from circumference to circumference. Ne? This is a chord. It can be like this. This is a chord. It can be like this. This is a chord. I can draw a triangle. No. Okay. Even though it's like this, but it's fine. These are chords. Ne? I'm not sure if you understand it. Ne? Yes. So, the last question. I'm wiping here, Mus. I'm wiping. Then the diameter, it is, yes, it's a special chord because it passes through the center. I'm wiping here, Mus. We are moving. Hey, guys, screenshot, Pela. Screenshot. I use the chord AB. You said you're going to do. My friend. On the next live, my friend. But please follow me, my friend. On the next live, you can see how this question has drained me, my friend. And I was trying to be as slow as possible, but unfortunately, I'm really sorry, my friends. Those who are waiting for the prop, ne? I'm really sorry, but thank you for participating, But on my next live, I promise proportionality theorem. I promise proportionality theorem, my friend. Ne? I promise. Tomorrow even. The next live is tomorrow. It's going to be proportionality theorem. Because now, everything I have to be clear and show, the things that I talk about, I'm not claiming, Yes, area of triangle, whatever. Yes. So I'm wiping. Going once, going twice. Let's move. Now, number C. Let's do number C. Okay, we are done with this one. We're done. If you are late, I don't know. So number C, we are proving that angle P C is going to be equals to A angle B C. We have to prove, yes, same time, same place, 12 o'clock or 12:30. Sometimes I tend to be late because sometimes at 12 o'clock I pray, guys. It's very important to pray. Don't mind my mouth, guys. I'm a bit sick. Ke siso, ntwe ke siso. Le sara ke phumole melo. Silo se ke siso se. Abo, ayetlo, abo. If you have a good remedy, suggest, my friend. Suggest. But it's fine. Yes. A angle PC. A angle PC. It's equals to A angle B. D. Ha. A angle PC is equals to A angle B D. How are we going to go about it? Can I get this one? I'm demanding 100K, Shem. This one I'm demanding 100K. Is the last question of the day. We are talking now. I want us to talk on the comment section. This one is going to be a match, yeah? So they want to prove that this angle is going to be equals to A angle B, A angle BD. A angle BD, it is B2, guys, ne? A angle BD is going to be B2. Do we agree? Yes or no? To make things simple. A angle B, no, BD, sorry, not C, D, ne? A angle BD. A angle BD. You proved that angle P is gonna be equals to angle B. I didn't prove that. The angles that I proved is A4 plus A3 is gonna be equals to A2. And again, I proved that AB1 is going to be equals to B3. Now I have to prove that this angle is going to be equals to A angle BD, this angle. I have to prove. I don't know how, but I have to prove that. We have to prove that. I don't know how. Yes, it's grade 11. A angle PC. Oh, I see it. Here I see it. I'm going. This one. Can I have 100K? I see it. Hey, I was surprised. I was even shocked. Or yo, I get lo ira di pambuwa living. But whenever you have a third eye, it's going to be fun. And it's guys, you can prove it very easy. Whenever we reach 95 likes, I'm giving you the clue. But the rest, I'm telling you none. I need 100K likes. People who are serious, they will stick around, People, please guys, I like why are you like it? I did some mime. Are you go 95? Let's have 95. Oh, let's have 95. I will show you now. No. Within a space of few minutes, You are lost. How are you lost, my friend? How are you lost? So that we can unlose you. So that we can unlose you. How are we lost? How are you lost? Can I get a 100K? So okay. Saying, and I'm writing to the But I'm going to help you in this question. But can I get 100K? So guys, the clue that I'm going to give you, ne? The clue that I'm going to give you, because obviously I'm not the one who is going to write, so I can't break with the answers. So the clue that I'm going to give you, I'm just going to say, look at the parallel lines. Look at the parallel lines and think abroad about that. That's the clue. That's the clue. No, share your confusion, Queen. Share your confusion so that we can help you. Share your confusion so that we can help you. Look at the parallel lines. And yeah. No, co-interior angles. Because you see the roll hazel. If you are using the co-interior angles, it's going to be complicated, because now you will be involving the values, because here we are not dealing with the values or figures. We are dealing with proving. Ne? It's like theory. It's like yes. Well, whenever you're dealing with proving, you're going to be involving figures, and whenever you involve that 180, everything is going to be complicated. Ne? Yes, mathematically correct. Yes, they are mathematically correct. But how are they going to help you to prove this? The moment you include figures. Maths, it needs a timing, guys. Maths needs just timing. There's a time for everything. It doesn't mean whenever you are using not similarity, guys. I never talked about proportional theorem. I never talked about the similarity. I never talked about proving, doing ratios. No, those things I promised to deal with those things tomorrow. I promised to deal with those kind of the things tomorrow. Yes. So okay. Now it's fine. I will forgive you. Thank you for 98 likes. For 98 likes. I will just say 98 likes. So guys, let me help you. Ne? I just need a yes or no. 12 o'clock, my brother. 12 o'clock, ne? 12 o'clock. So I just need a yes or no. So do you see the parallel lines? Yes, no? And please give me the parallel lines. Which lines are which lines that are parallel? Please give me the parallel lines. Yes, thank you very much. Which lines that are parallel? Which lines that are parallel? Yes, A, P, and AC, right? A, P, No, PC, guys. PC and AD. Ne? Hey, sorry. Maybe this one distracted you, ne? PC and AD. They're the ones that are parallel, right? So now let's deal with this. Ne? Do you see the F? The F which looks like this. Yes, no? Yes, no? Yes, no? Yeah, but not now. Not now. Not now. Calculus I do. Do you see the F that looks like this? Ne? You are going to answer me. Ne? So now, since we see the F, ne? Since we see the F, have that F in your mind. Ne? Have that F in your mind. So I want you to give me the answer. Ne? I want you to give me the answer. So the P that we are supposed to be proving is going to be P1 plus P2. Yes, no? Do we agree? Yes, no? Yes, no? Can I get a yes, no? This is the one that is that is A angle PC. Can I get a yes, no? Thank you very much. Yes, it's going to be yes. So what is this equivalent to? You have that F in your mind, right? You have that F in your mind. So what is P1 plus P2 equivalent to? Yes, even if I just said P, it's okay. Yes, yes, you are very correct, my friend. You are very correct. Yes, P1 plus P2 is going to be equals to A1. We agree on that. And what is the reason? What is the reason? What is the reason? It's going to be corresponding angles, right? Corresponding angles. And guys, whenever you are writing what corresponding angles, specify which ones are they parallel. So which sides are they parallel? Okay, let me just I want to bring this closer. No, Yiri. Okay, right, let me just write it beneath. So reason, I want you guys to see this, ne? It's going to be corresponding angles. And again, you're specifying PC is parallel to AD to show that you're sure about what you're doing. So now, do you see? I'm giving you yes, because AD is parallel to TC. So because of I'm helping you, I don't want to brag or hey, I found the answer. You're the one who's supposed to find the F. Draw the F shape on the diagram so that they could see. I don't have much colors, and I think it's gonna be messy. But this is the F. Ne? This is the F. Do you see, Mos? And this A1 is the one which is equals to P1 plus P2. Reason PC parallel to AD. Finish, ne? Now, do you see that PA is a tangent? Can I have a yes, no? Do you see that PA is a tangent? Ne? Do you see that PA is a tangent? Can I get a yes, no? Thank you very much, ne? So whenever I think PA is a tangent, I have to think about the theorems which are related to the PA. So I'm going to draw a simple triangle, ne? So I'm going to draw a simple triangle which is related to this tangent. Like I said, I'm helping you. Okay, yes, also PC, thank you very much. So now I'm going to draw a small circle. Ne? I'm going to draw a small circle. Ne? And I'm just going to draw the tangent that we are talking about. Ne? Because hey, we were fighting not so long ago about this theorem. And I'm going to draw this tangent. Remember, this is the P and this is the A that we are talking about. And I'm going to draw this so do you see what this is B2? And do you see what I'm having the only D1 portion? And do you see what I'm having the point A here? And do you see what that A1 is going to be located here? That A1 is going to be located here. Now do you get the picture? Do you get the picture now? I took the portion. Ne? I took the portion of the triangle ADB. Do you get the picture? Then we are done with this question. you are done with that question. If you get the picture, you are done with this question. You are done, absolutely done with this question. Done and dusted. Or maybe lesabelael. Do you still have that? You are still not sure who is up for an argument here. I need those ones. Who is up for an argument here? Who is up for an argument? Who wants to argue this? You are done with this question. Now we are going back to our script. You are done. Because you can see who PA is a tangent. Ne? PA is a tangent. And here's my PA. PA is going to be the tangent. And we saw how this angle is going to be equals to A1. And A1 is going to be equals to B2. We are done. Straightforward. So now let's write on the diagram, put a hand on A and B. Okay, on the diagram, A and B. Here is it. Oh, you want to see it? Here is it. You see? A, B, and D, they're on the point. Ne? Thank you for the 100K. A, B, and D, they're on the point. They're forming the triangle in A1 and B2. This is the circumference, minor, and this is the major. A. This is the segment, minor segment. This is the major segment. The angle at the minor segment and the angle on the major segment. So on our script, what are we going to write? We said to P1 plus P2 is going to be equals to A1. Reason corresponding angle PC is gonna be parallel to AD. Another one, we are going to say A1 is going to be equals to B2. Reason tan chord. So therefore, P1 plus P2, they are going to be equals to B2, I mean B2. What is the reason here? What is going to be the reason? The reason is going to be okay, let me write the reason. Both equals to A1. Then therefore A angle PC is going to be equals to A angle BD. Chaile. Proven. We are done. Saivala, Linda. Saivala. Are you happy? Can I get a thumbs up? Can I get a thumbs up? Can I get a thumbs up? It's 4 o'clock now. Can I get a thumbs up? Thumbs up. And my followers. Follow, guys. You know how you need this content. I'm telling you. Follow, guys. Follow, like, share, subscribe. You follow, you like, you share, you subscribe. Etara. You follow, you like, you share, you subscribe, you get free knowledge. But for private lessons, guys, don't forget, 200 per month. 200 per month for this whole thing, right? And I'm just hoping, Hori, this like I am just hoping or live and irrespective of the negativity, those negative comments, like I'm glad or you've been here with us, I'm glad or you've been here with us, joining the live session up until the end, up until the end, and yeah. Yes, thank you, you're wonderful. Thank you, Proudy, thank you very much, and God bless you, my brother. Thank you. wise words are always appreciated in this house. So thank you very much and God bless you. And yeah, thank you very much for joining. I believe we reach the end of this session. And yeah, guys, quick one. If you need, please subscribe to my channel. Can I have at least 10 people will be appreciated, guys. 10 of you guys appreciated, just to push my algorithm. And I will post this recap for this live. I will make sure that I post the recap of this live, né? And I just need people who are loyal, because some people, they are just here just to root. I always like yes. We're still going to do more of them. Tomorrow is similarities. Tomorrow we are going to, the demand is going to be a little bit higher. Last time I did it, similarity, but I didn't like the way I introduced it, ne? Thank you very much. Thank you very much, Mrs. Yeah. Yes. Mara ba roa mara lentse ba roa re tlo continue re thuse bana wa ntlhanwa. Thank you for the subscription. Ba roa go the comment section mara ha rena taba le bona bo, because the ones who needs to be the ones who needs this knowledge, who needs to be taught, and who is allowing themselves to be taught, they will be taught. Remember, God help those who help themselves. Yes, I'm going to be live tomorrow. Yeah, arrange, bravo, arrange. Yes. Okay. Interesting. Please go continue, guys. Continue taking your lives very serious. Yes. Yeah, he must subscribe, follow. He must subscribe, your little brother. Subscribe. I will groom him very well. So yeah, I've reached 100K. So my last words, I will just say, if you know you need help, please, there's my website. But my website is under maintenance, because not all people, they wish you well, ne? Salute, me broro. Salute, Brayaga. Not all people, they wish you well. God bless you too. Not all people, they wish you well. Heartlim. Plus Heartlim, follow. I will help you. Groom him very well. These people, they need help. More clarity, helping each other. No one is perfect. I'm not here to prove any point, ne? I'm not here to prove any point. Just here to help you guys. Not here to prove a point or lend your corner mates or what. Thank you for the gift, Little. Thank you. Not everyone is perfect. But thanks for your participation. For extra lessons, blrtutoring.co.za. And whenever you get there, guys, it tells the website is under maintenance, ne? And because of I was hacked, and I wasn't hacked, the person was trying to change everything there, was trying to do the shenanigans. I don't know which programmer trying to sabotage my website or whatsoever. So the website it automatically blocked itself, but obviously we created some platform so that people, they can access the number. So even though you search BLR tutoring services, it will show the page, but in front it will just say Warawara under maintenance. Sorry for the inconvenience, but we left the numbers there. So if you need tutoring lessons, you are late, man. I'm closing now. But how are you, my brother? Welcome back. It's just a hi and bye, ne? Yeah, but if you need very help, the quotation is just 200 per month. Yeah, 200 per month, maths and physical sciences. But if you are skeptical about the numbers, you can even DM me. I will give you my personal number, or DM Mrs. TK. She will assist you. Everything, like we are one, everything goes hand in hand. But otherwise, thank you very much for your participation. Make sure you like, share, and subscribe to the channel. Yeah, thank you. See you on the next live.